So what are the different kinds of resonators that are around us? Let's go down the list. The first one is called a Helmholtz resonator. And a Helmholtz resonator is nothing other than your water bottle. Have you ever done that? And blown over it? What do you hear? A humming sound, right? If that water bottle was constructed properly, like this, it will be called a Helmholtz resonator. So before your tuning, like your digital tuning came around, Helmholtz resonators were used to absolutely tell you what the right frequency was of any instrument, of any room, how it would project out. If I played this frequency, how that would project out into the rooms. Greek amphitheaters were actually constructed by using Helmholtz resonators. And all it is a water bottle just constructed in a way that it gives off the particular frequency that you want. And as always, this has to have a formula associated with it, because that's how physicists think. So each Helmholtz resonator will have a particular frequency that depends on the speed of sound, which is V, divided by 2 pi, A, which is the cross-sectional area, L is the effective length, and V is the volume. Oh, this should be of the neck. And this is also of the neck. Let's do a question. Suppose we have a 1 liter bottle with an effective length of 5 centimeters and cross-sectional area of 3 centimeters squared. This should be squared. My bad. Find the resonant frequency. We have a formula.
Equals V over 2 pi times the square root of A over VL.
Okay. So this question gives us the volume, which is 1 liter. And in SI units, it will be 0.001 meter cubed. It gives us L of 5 centimeter. There is a problem. And it gives us an area of 3 centimeters squared. So what do we do with centimeters? We convert them to, good. How do we convert them to meters? So L would become 5 centimeters. How many meters in a centimeter? 100. So it'll give me what? 0.05? And area is centimeters squared. What does that mean? That means it's centimeters times centimeters. So how do we convert that? 1 meter divided by 100 centimeters times 1 meter divided by 100 centimeters. Right? We have to do it twice. So 1 centimeter goes away and 1 centimeter goes away. And I will get 1, 2, 3, 4. 3 times 10 to the minus 4 meters. Oh, you could use your calculator. It'll be 0.0003. And then what is the V? V is just the speed of sound at room temperature, which is 344 meters per second. So plug all of those numbers in and give me and the answer in hertz. And remember, a Helmholtz resonator would look something like this. So this is the cross-sectional area, this is the volume, this is the length, and that's the area of this little bit. What is it? Okay. Somebody else. Oh, wait, confirming? Okay. Woohoo! 2 confirmations. That's our answer. We're good. So where are Helmholtz resonators used? Again, they are used, they used to be used a lot more, but now that we have the digital versions of them, they're not used as much. However, even in constructions now, sound engineers still use them to make sure that their digital scales are doing the work properly. Like people who want to be really precise. Okay, and also, without you realizing, you are using a Helmholtz resonator every day. And that is the muffler in your car. Does anyone know what a muffler does? It lowers your car engine noise by reversing it and sending it back to the engine. It muffles the noise. That's why, you know those bikers, right? When you hear that loud sound, all they've done is they've taken out their Helmholtz resonator or a muffler. That's all they've done. So the noise of the engine actually comes out. Can you imagine if that was true and none of the cars had a Helmholtz resonator in it? The noise pollution that would be with the number of cars we have. Oh, I don't even want to think about that. Oh, has anyone gone to like Knoebels and sat in those old cars? You know, right?
Yeah,
Are they loud?
they're very loud. I go there every year
Perfect. Do you know why they're loud?
because they do not have mufflers on.
Because they don't have a Helmholtz resonator on them. Yeah. So the next time, think of Helmholtz resonators when you go.